All right, hello math fans. All right, so this is day 4, and this is going to be adding and subtracting radicals. All right, we're going to also do a little bit of distributing, a little bit of foiling. It's all very exciting. Okay, so this is the deal. You can only add and subtract radicals with the same radicand. And you're like, what the heck is a radicand? Okay, so this is the deal. This number underneath here, that is called a radicand. Okay, it's a very exciting name. That's a radicand. So you can only add numbers with the same radicand. Okay, so it's really, really simple, but this is what you're going to do. Let me give you an example. 2 root 3 plus 4 root 3. Okay, this is the way you have to look at it. Do you guys remember when we did this back in the day? If I did 2x plus 4x, and if basically I'm saying, hey, you've got 2 x's, I'm giving you 4 more x's. How many x's do you have? I've got 6 x's. It's the same thing with radicals. If you've got 2 square root of 3's in your hand, and your friend says, hey, you want 4 square root of 3's? And you're like, well, you know what? I already have 2. Okay, I'll take 4 more. How many do I have in my hand right now? I have 6 square root of 3's in my hand. All right? It's exactly the same thing. So please don't say 3 plus, add the 3's together and say 6 root 6. Boo! That's really bad. Okay? Because if you have 2 root 3's and I hand you 4 more root 3's, you don't have any root 6's in your hand. You only have root 3's in your hand. Okay? So the only way to add these guys together is if you have the same number under the radical or the same radicand. Very, very important. And then basically what you do is these numbers here, which I just did the 2 and the 4, that's what you add together. Okay? That's really, 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 really important. Okay? So 8 square root of 3 minus 6 square root of 3. Same deal. You've got 8 root 3's in your hand, and I'm taking away 6 of those because I'm a big mean bully and I want to take those away. Okay, so if you have 8 root 3's and I take away 6 of those root 3's, how many root 3's do you have? You only have 2 root 3's left. Okay, that's how adding and subtracting works. All right, sounds pretty reasonable. Let's see, what about square root of 27 minus square root of 12? And you're like, ha! You can't subtract those because they're not the same. And I would agree with you. But what you need to do is simplify them first. Okay? So square root of 27, well, isn't that saying 9 times 3? So isn't that 3 root 3? And what's square root of 12? Isn't that 4 times 3? Isn't that 2 root 3? Oh! By simplifying sometimes, you actually have the same radicand after you simplify it, and that's what you need to do. So you want to simplify first. Okay? So 3 root 3's minus 2 root 3's is 1 root 3, or just root 3. Please don't tell me 1 root 3. It's like saying, how old are you? I'm 1 times 15. Okay, boo, you don't say that. You say I'm 15. So don't put a 1 in there if there's a 1 as a number in front of the radical. Okay? That's actually pretty mellow. But again, simplify, and sometimes you do have the same radicand. All right, so let's do another kind of problem here. Square root of 6. Okay, let's do another problem here. If I have the square root of 6 times square root of 12 minus square root of 24. All right, what you're doing here, math fans, is you are distributing. Okay, just like the old days. So it's really 6 times 12. So I'm not going to multiply together because if you notice, remember that from back in the day, I can simplify that a little bit, even before I do anything. And then it's minus 6 times 24. Do you agree with that? Everything inside, you multiply this stuff together, and then this together. So 6 times 12, isn't that 6 times 6 times 2? And isn't that 6 times 6 times 4? Right? Okay, because you got your pairs here. So what I'm going to do is I'm going to pull that out, and I get 6 root 2. And if I pull this out, I get 6, and I got root 4. Well, isn't root 4 a perfect square? Yeah, it is. So 6 times 2. I just pull the whole thing out. Remember, if you use everything under the radical, you're done. Okay, the radical goes away. So really, I have 6 root 2 minus 12. And that's my final answer. Can't combine them together because this has no radical. So 6 root 2 minus 12 is just 6 root 2 minus 12. Okay, let's try a couple more of these guys. But that's just distributing. You guys should recognize distributing here. So if I said square root of 3 times square root of, or let's do 2 square root of 3 times 4 square root of 3 minus 3 square root of 5. That's just kind of a random problem. Okay, so again, I'm going to distribute to there and to there. Well, remember, multiply the stuff inside the radical and some stuff outside the radical. So 2 times 4 is 8. What's root 3 times root 3? Isn't it just 3? You could write root 9, but if it's the same number of the radical, it just becomes that number and the radical goes away. And let's distribute this guy now. Minus 2 times 3, which is 6, and root 3 times root 5 is 15. Root 15, okay? Make sure you put the root there. It doesn't. The only time a root goes away if it's the same number. So square root of 7 times the square root of 7 is just 7. But the square root of 7 times the square root of 3, you can't, that's not the same, so it's actually the square root of 21. Be careful about that. Anyway, back to this problem. It's 24 minus 6 root 15. That's it, math fans. That's all I can do. 24 minus 6 root 15. Okay, let's try another one here. 4 square root of 5 times 2 square root of 15 minus square root of 5. Okay, I'm going to distribute to both terms. Okay, and if that helps to put a 1 in front of here to say, oh, it's 4 times negative 1, that's cool. But 4 times 2 is 8 root, and I'm going to write it this way. So it's 8 times root 5 times 15 minus, and then 4 times 1 is 4, and that's 5 and 5. Or you could just say, oh, look at that, I got a root 5 and root 5, that's just 5. Okay, you could have done that. That 8 times 5 root 5, or 5 times 15, let's say 5 and 15 is 5 times 3. So the 5 comes out, it's 8 times 5, and you have a root 3 left over, minus 20. So the answer is 40 root 3 minus 20. Okay? That's pretty mellow. All right, so let's see. Let's do some nice friendly multiplication here. What about this? Square root of 5 minus 3 squared. All right, a bad thing to do, horrible thing, boo type of thing, is to say, oh, square root of 5 squared is just 5. Square root of 3 squared is negative 9. So the answer is negative 4. Okay, that is number one bad algebra mistake. You guys should remember, when you have a parenthesis and there's a squared on the outside, what do? You write it twice. Okay, so it's square root of 5 minus 3 times square root of 5 minus 3. And then you FOIL. Okay, root 5 times root 5 is 5. Root 5 times negative 3 is negative 3 root 5. Negative 3 times root 5 is negative 3 root 5. And negative 3 times negative 3 is positive 9. Okay, that's what you got to do. And then you combine like terms. Well, 5 plus 9 is 14. Negative root 3, or negative 3 root 5 minus 3 root 5 is negative 6 root 5. And that's your final answer, 14 minus 6 root 5. But man, you got to write it twice. If you forget to write it twice, it's just automatic big old X on your paper. Okay? So let's do another one here. Root 7 minus 3 and root 7 plus 6. Okay, again, this one's nice because this one you don't have to remember to FOIL because it's already in FOIL form, right, to do that. So it's root 7 times root 7, which is 7, first outer, plus 6 root 7, inner, minus 3 root 7, and last, minus 18. Combine like terms, 7 minus 18 is negative 11. 6 root 7 minus 3 root 7 is plus 3 root 7. And that's your answer. Okay? It's not bad. Let's do a little more complicated one. 2 root 6 minus root 5 times 3 root 3 minus 2 root 8. All right. Let's just FOIL out. Okay, it's a lot of stuff to do here. The first term, 2 times 3 is 6, and I'm just going to put 6 times 3 in the radical. Okay, outside, minus 2 times 2 minus 4, root, and I'm just going to write 6 and 8, just because I think I can simplify that. Inside, minus, and if you want to again, put a 1 here. So minus 3 root 5 times 3. And last is plus 2 times 5 times 8. Okay, now I need to put it all together and see what I can simplify. Well, I know that is going to be 3 times 3. So 6, 3, 3, and 3. So I can pull out a pair of 3s. And I get 3 on the outside. And I get 3 left over. So I get 18 root 3. That's my first term. Okay, this next one, 6 and 8, I can write that as 3 and 2 and 4 and 2. Now if you realize, I actually can pull a pair out and a perfect square. So I have negative 4, and then I have a pair out. I get a 2 here, and pull out a 4. I get another 2 here, and I got 3 left over. So that gives me negative 16 root 3. Okay? And this next one, I can't really do anything with it. 5 and 3, there's nothing there. So it's minus 3 root 15. And this one, I can actually simplify the 8. Okay, so it's plus 2, and it's 5 times 2 times 4. So I can pull the 4 out. So it's plus 2 times 2 is 4, and I have root 10 left over. So the only thing I can combine are the first and second terms right here. So 18 minus 16 is 2 root 3 minus 3 root 15 plus 4 root 10. Okay, 2 root 3 minus 3 root 15 plus 4 root 10. That's probably the more complicated one out of all of them, but it's really not, it's not too awful. All right, so let's see. Let's try another one here. How about 3 root 50 minus root 18 plus 4 root 32. Okay, well, again, you got to simplify it first. So that's 50 is 2 and 25. So I can take a 5 out, and I have 2 left over. 18 is 9 times 2, so square root of 9 is 3, and I got 2 left over. And 32, now some of you might say, oh, it's 8 times 4. And that's okay, but 8 is also 4 times 2 times 4 then. So I can actually pull a 4 out. That's probably the best way. But you already have a 4 here, so it's really 16 root 2. So plus 16 root 2. So I have 15 root 2 minus 3 root 2 plus 16 root 2. And 15 minus 3 is 12. 12 plus 16 is 28 root 2. Okay? Okay, a couple more here. 2 plus root 7, 2 minus root 7. What does this look like to you? I mean, you guys should look at this problem and go, I kind of recognize that from one of the chapters. What is this? Okay, this is actually a difference of two squares. Okay, do you remember when we factored if it was x minus 3 and x plus 3? Do you remember it was x squared plus 3x minus 3x minus 9. So x, these guys canceled. X squared minus 9. Well, if you notice, it's in order to recognize the difference of two squares, okay, you had an x and x, you had a number, the same number and the same number, and what was important here is plus or minus and plus. Okay, so I actually have the same thing here. The 2's are the same, the root 7's are the same, and I have plus and minus. Okay, so when I do the problem, if I would actually FOIL it out, you get 2 times 2 is 4. Outside is minus 2 root 7. Inside is plus 2 root 7. And last is minus, remember root 7 times root 7 is just 7, so minus 7. And these cancel. So I have 4 minus 7, which is negative 3. That's the answer to that. All right? So just kind of watch what you're doing. If you have a difference of two squares, it's great. And you really only have to do the F and the L. Okay, because the OI cancels, right? Here's the OI right there. Cancel it out. Okay, and the only thing you're left with is Florida. Ooh, Florida, nice and warm, sweet. Oh, sorry. Okay, so let's try one more of those guys. 2 root 3 minus 6, 2 root 3 plus 6. Okay, if I FOIL it out, I get 2 times 2 is 4. Root 3 times root 3 is just 3. Outside, plus 12 root 3. Inside, minus 12 root 3. And last, minus 36. So it's 12 here. So 12 minus 36 is negative 24. And once again, math fans, those cancel each other out. So my answer to this problem is negative 24. Okay? So that's it. That's it with adding and subtracting. With squaring, doing FOIL. So that should be it. All right, math fans, have a great day. Adios. Goodbye.